But 10.4 is all about adding and subtracting radicals. And here's in everything they do in 10.4, all the objectives that they look at here, it all comes down to basically doing the same things when you're going to add, subtract. And they stick with square roots. They don't go to third roots or fourth roots, so they kind of keep it so it's all the same. But basically, here's the things you have to have. If you do stretch out and go beyond square roots, the radicals must be the same index and then the radicands, which is what's on the inside, you don't see that word a lot, especially if you don't talk in math terms a lot. But the radicands, what's inside the radicals, must also be the same. Do what? Yes, if they're different than their radicands. Okay, so when the indexes are the same, square roots, they all have to be square roots, they all have to be third roots, something like that. If what's on the inside, if the radicands are the same, then on the outside you add or subtract the coefficients, whatever the signs are. Add or subtracts. And when we're talking about the coefficients here, the coefficients are what's in front of your radical there. So add or subtract the coefficients in front of the radicals. Okay, but the big thing on this one is that when you do this, you do not change the inside of the radicals. The only thing you have to change is what's on the outside. That basically, if you want to think about it this way, every radical is like a variable. So if one's a square root of 5 and the other one's a square root of 6, it's like trying to add an x and a y together. It's like adding an apple and an orange. Well, yeah, you have two fruits, you have two vegetables, whatever you're going to call them, but you can't put them together. You can't take 6 apples and 7 oranges and get 13 bananas. They have to stay in the same thing as you go through this one. Okay, and all the different objectives, they're basically going to just keep coming back to those same two things here. So objective 1, they're just going to give you some basic straight up problems and have you work on them. 6 squared 13 plus 9 squared 13. Okay, so both square roots, both 13's on the inside. So if that's the case, you're just going to do 6 plus 9. And it's almost like when we did factor by grouping, when we took out the common terms, kind of did that same thing. It's kind of along those same lines that you'll take these two 6 plus 9s together and put the 13 here. So it's really just 15 squared 13. They try to go back, I think in the book they'll probably talk about that this is, they kind of take you back to when we were doing the 4 terms and you had the factoring and you pulled out combined like terms, that kind of thing. It basically kind of take you along those lines. The only thing you really have to be careful of when you do some of these is that you may get something like 9 squared of 5 minus square root of 5. If they do not give you a number in front of the radical, just remember that there's always a 1 there. So this one would be 9 minus 1, which would be 8. And square root of 5. Nice. Okay. Other than that, there's really not any tricks they can do on this one. And it should be that they give you these two square roots the same. Again, if they gave you one, they may try to be sneaky on you and give you one that's, I don't think they'll do this, but they may give you like 4 square root of 6 plus 5 square root of 7. Well, if they gave you that one, it's already simplified. That would be one where it's not possible. This would be a radicand because you cannot add these numbers together. Or if you grew up in Lauderdale County, it's a radicate. You can't do it, right? Okay, now here's where they kind of, and I don't think they'll give you one like this because the very next objective that they give to you is going to be one where they give you two numbers that are not the same. You get 2 square root of 8 plus the square root of 72. So again, I'm pretty sure they're not going to give you one like this because this is kind of setting you up for the next part that's coming here. That if you get one like this where you have different radicands, the numbers on the inside are different. Because here's what they're going to want you to do. That they should basically give you everything in the first part where they're all the same. And then the second part says, all right, if the radicands are different, you're going to have to simplify or break them down. Until they're all going to be basically the same numbers. So if radicands are different, break down the radicands as much as possible. And then see if you can add and subtract. Okay, so if you get 2 square root of 8 plus square root of 72, you're not going to put just not possible. This is one they're going to take these numbers that you have, and you're going to take the 2 square root of 8, and again, you're going to take the 8 and start breaking it down. And I think everything on this part should probably be square roots. I don't think they worry about any third roots or fourth roots or fifth roots. I think everything here they'll keep it square roots. So if you take the 8 and start breaking it down, well, 4 times 2 is the only option. Square root of 4 is 2. So you've got 2 times square root of 4, which is 2, and then times square root of 2. So for this one on the outside, you've got 2 times 2, which would make that 4 square root of 2. Okay. If you break the first one down, and it's got square root of 2, there's a really good chance that that second number is also going to have a square root of 2 in it. So it kind of gives you a hint what to look for. That on the second one here, if you take this one and break it down, 72, you can make it 36 times 2. But square root of 36 is a perfect number, right? So you can take the square root of 36 that's here, make that a 6. Square root of 2. So now you're going to do 4 square root of 2 plus 6 square root of 2. Now you do have the same radicands. So then you can take the 4 plus 6, add it together, and make it 10 square root of 2. Okay, so they'll go from everything being the same in the first objective, just making sure you add and subtract the numbers in front. Objective 2, then they change it so that now you have different radicands, and for those you're going to have to take the numbers and break them down, and eventually on these you should have the same radicands at the end, and then you go back and add or subtract the coefficients that you're going to have in front. So we'll have 4 square root of 98 plus the square root of 8. Okay, And if you want to start breaking these down, again, now, and you may want to go with the smaller number first because it should go a little bit faster. With square root of 8, again, if you make that 4 times 2, and you may go, well, hey, we just did square root of 8 back here, right? Square root of 8 was 2 square root of 2. Well, yeah, you could kind of keep that in your back pocket there. You can make that 2 square root of 2. Okay. And for these, as long as there's just two terms and they ask you to add or subtract, you're pretty much almost guaranteed that this number, when you break it down, is going to be 2 times something. So if you take the 4 square root of 8 that's here, take the 98 and rewrite it as 2 times something, well, that's going to be, if you divide it by 2, that's 49 times 2. And there's your perfect square root right here with 49. So you can take the square root of 49 and make it 7. Okay, 4 times 7 is 28. Square root of 2. And then we're going to add this 2 square root of 2 to put this 8 back here. And again, once you're there, you've got the same thing in the radicands. So now you can do the 28 plus 2, make it 30. Square root of 2. Yeah, so if they give you two terms, you're pretty much guaranteed that those two terms are going to have to be the same. Because if not, you've just done a lot of breaking down and then there's nothing you can add or subtract from those. Okay, objective 3. This is one where they're going to give you 3 terms. So this is one where it's kind of iffy. You may get 2 terms that's the same and you may get one that's different. So that you may have 2 parts you can add and 1 part that you're not able to add. Or it may be that all 3 might be the same. So it just depends on the numbers and how they throw this out to you. So it could be any one of a number of different ways when you go through this one. But it's still on the same setup here. So this one we'll do 2 square root of 20 plus square root of 80 plus 11 square root of 5. Okay, 11 squared root of 5. Nothing you can do on that one because it's done, so this part back here is finished. For these, start breaking these down. And again, I would go ahead and try to divide the 5 on these because there's a good chance that they may all be. They may not be, but it might work. So if you take the first one here and rewrite it from square root of 20, if we think about 5, that's going to be 4 times 5. Well, square root of 4, that's a perfect number, so we can make that a 2. So that's 2 times the square root of 5. So that's going to make that one 4 square root of 5. Okay, and again, this one we know it's not going to simplify, so we can just break that down and leave it there. 80, again, think about with a 5 for that part. 16 times 5. Well, square root of 16 is 4. So that's another 4 square root of 5. Okay. So when you take those 3 and break it down, they're all square root of 5. So now you can go back and do 4 plus 4, which is 8. 8 plus 11 would make that out to be 19 square root of 5. Okay, so 2 terms, 3 terms. Again, if it's 3 terms, they may or may not be the same number. You want to hear where we actually get something a little bit different. Let's do 9 square root of 5 minus 5 square root of 63 plus square root of 28. Okay, so this is one that you can tell it's different right off the bat because if you start breaking this with a square root of 5, there's no way 5 is going to go into 63, so that's not going to work. So these are going to have to be something different. If you take square root of 3 and start breaking it down, first thing I'm thinking of is 9 times 7. But again, 9 is a perfect square root, so we can take that 9 out and make it 3. So it's 5 times 3 times the square root of 7. That makes it 15 square root of 7. Okay, again, we couldn't do anything with this 9 square root of 5, so it'll stay just like it is. With square root of 28, again, 5 is not going to work, so in this case it's 7. If you break it down, it's 4 times 7. That square root of 4 comes out to make it 2 square root of 7, so this comes out to be plus 2 square root of 7. Okay, so these two are the same. So we can do negative 15 plus 2, which is negative 13 square root of 7. This one was different, so it stays all by itself. And then that would be your answer that you're looking for there. So again, if they're same radicands, you can add them together. If they're different radicands, you cannot add them together when it comes down to it. They're radicands. So there's a radicand and a radicand. Okay, and then the last objective in section 4. Same thought process, still having you add and subtract on this one, but for this part, they're going to add in variables. And remember when you add and subtract variables, it's kind of like when we're doing the radicands, that you had to have the same radicands. Well, if they start giving you variables, if you're going to add and subtract variables, the variables have to have the same power to either add or subtract. So if you had, 3x squared plus 2x, you can't add those together because they have to have the same power when they start going back and do this one. So the only thing they're going to do different is now they're going to start giving you numbers that you have, and you have to kind of break these down a little bit. So when you start to break them down, when you start trying to put these together, remember, if you've got something that's, 3x squared and the other one's just an x to the first power, you're not able to add those two things together. They would have to stay separate. Okay. So that was just something to kind of throw at you. All right, here we go. So for this one, let's go with 3x squared times the square root of 48x minus 27 times the square root of x to the fifth. Okay, so on the first term, 3x squared is good. We're going to take the 48, though, and start breaking it down. Again, if you want to think about it this way, we have the square root of 48 and then the square root of x. Then again, you can think about each piece as being like a separate piece on the inside. If you start taking the 48 and breaking it down, you can divide it by 2, but this is one of those, if you kind of think about some of the numbers. You could also do it as 3. 3 times 16 would be 48. So there's your perfect square root with the 16, so you can make that 4 square root of 3. Again, we had the square root of x, so we had 3x squared times 4 square root of 3 times the square root of x. So all this stuff on the outside you can multiply together. It's 4 times 3, so that would be 12x squared. And on the inside, you've got a 3 times the x, so you can make that 3x. Oh, hang on, one second back here. I put this square root in the wrong spot. Back that 27 was supposed to be on the inside. How about that? Sorry about that. So take that second term, put that 27 on the inside with x to the fifth. When I looked at it, I wrote it in there the wrong way. Okay. And more than likely, with these terms the way they're set up, if this one is square root of 3x for the radicand here, this one more than likely is probably going to be the square root of 3x. So if we take this part and break it down, 27, if you start to break it down, it is 9 times 3. Again, you can take the square root of 9 to make that out to be 3. So that's 3 squared of 3. And with x to the 5th, again, the index is 2, so we're dividing 2 into 5. So that'll go 2 times with 1 left over. So again, this is the power that goes on the outside. This is what's going to be left over on the inside. So we have x squared on the outside and 1x on the inside. Okay, so on the outside, you've got a 3 and an x squared, so we'll go ahead and put those two together. And then on the inside, you've got a 3 and an x. So now we got everything matching up. We've got a 3x on the inside. We've also got the 12x squared and the 3x squared on the outside. So we know that the inside is going to be square root of 3x because, again, you're not going to change what's on the inside. All we're going to do is add what's on the outside. So if we do 12x squared minus 3x squared, 12 minus 3 would make that 9x squared. Okay, so that last objective starts to get a little bit more tricky the way it is. Let's do one more of those. See if I can write it the correct way this time. 16z to the third square root of z minus 11 square root of z to the 7th. That's what. Okay, first term, nothing you can do to break it down because there's just the square root of z, so this number is what it is. Okay, with the z to the 7th, though, that part we can break it down, so we're just going to take this thing and divide 2 into 7, which will go 3 times with 1 left over. Again, this power goes on the outside, and this power goes on the inside. So we're going to have a z to the third on the outside, and then 1z on the inside, and 11 that was still here out front, it's still going to be there because we didn't do anything with any numbers, it was just the variable part. Okay. Square root of z is the same on the inside, and on the outside they're both z to the third. So it says 16 minus 11, which would be 5 z to the third, and on the inside, that square root of z stays the same. Okay, so biggest thing to remember is really when you start adding and subtracting is as long as the variables are the same, you just add and subtract the numbers. You don't actually change anything about the variable.